Hi everyone. This is our last section from Module 5, and it's on inverse functions. So when you're thinking about inverses in general, an inverse is a function that works a question backwards. So like if a function does one thing, its inverse does the exact opposite. Or the way we usually think of it is they undo each other. And we use that all the time when we're solving equations. Every time we say, okay, I have a plus 5, I want to cancel out a plus 5, I use a minus 5, that's inverses. That's because plus 5 and minus 5 are inverses. They're the opposite and they cancel each other out. And it also works with multiplying and dividing. If I have a 10x and I want to cancel that 10, so I say, well, 10x means 10 times x. I'm going to use it divided by 10 to cancel out the times 10. So we use inverses all the time. But starting today, we're going to look at more complicated ones, not just single operation like adding and subtracting or multiplying and dividing, but the inverse of an entire function. So here's the number one most important thing about inverses. From now on, for your math classes, for as long as you take math, every time you hear the word inverse, the first thing you should think to yourself is switch x and y. That's what inverses do. They switch the input and the output. If you do that, if you switch x and y, or the input and output, it works the question backwards. Because you're saying, instead of plugging in this number and getting this number, I'm doing the opposite. I'm plugging in this number and getting this number. So it's going to work that question backwards. Now, we can do this not just for equations, but for any type of relation. So let's start easier than that. Let's start as simple as we possibly can. So for our first example, I gave you a relation, which is just an XY table in this case. Remember, a relation can be a lot of different things. It can be a table, a graph, an equation, a lot of different things. But for this one, I gave you pretty much the easiest one. I said, let's find the inverse of this relation here. And it's an XY table. Well, remember what I told you. The number one thing about inverses, they switch x and y. Now that can be done point by point. So for the answer to the question, my original problem was an XY table. My answer is also going to be an XY table. What I'm going to do is go through one point at a time, and I'm going to switch the x and the y. So if in my original relation, x is 7 and y is 3, then in my inverse relation, when x is 7, y is 3. It switches them. And then just do it for each point. Instead of negative 6 comma 0, I have 0, negative 6. Instead of 8, negative 4, negative 4, 8. I'm not changing the signs on the number. I'm not changing a positive to a negative. I'm just taking the two numbers and I'm switching them. Instead of 4 comma negative 2, I have negative 2 comma 4. Instead of negative 1, 7, I have 7, negative 1. And finally, instead of 0, 1, I have 1, 0. And that's it. That's the answer. Inverses switch x and y. If it's just points, if that's as easy as it can be, take the point, flip the two numbers, you have an inverse. Now, let's say we want to graph the inverse of a line. We're actually going to use the exact same concept. If I have a linear function, so that's all of Module 5, we've been talking about linear functions, lines. If you have the graph of a line and you want to graph its inverse, you can do that real easily, kind of using the same thing we just did with the XY table. I said pick any 2 points on the line, any 2 you want. Just find 2 that work. Find 2 where it crosses at a nice even whole number where x and y are whole numbers. Take those 2 points, switch the x and y and plot them. And remember, it only takes 2 points to draw a line. Draw the line that goes through those 2 points and you have the inverse. So let's go ahead and do that. Here we have a line, and for our example, we want to graph the inverse of the line. So what I want to do for this one, I want to try and find a couple of points that are very clearly on the line. And let's start with, and again, I'm just going to pick one. I'm going to start with this point right here. That light blue point I just highlighted. That's one where I can see it definitely is on the line, and it crosses right at a whole number. So that looks like it's the point negative 1 comma 4. So if I want to graph the inverse is going to have 4 comma negative 1. So I go over 4, down 1, and I'm going to plot the point right here. So the light blue and the purple points are inverses. Now just do it one more time because it takes 2 points to make a line. So I need another point that's definitely on the line. There's several that work in this one. I'm going to choose the x-intercept right here. That point right there looks like a good one. That's the point 1, 0, over 1 and up nothing. So its inverse, if I switch those two numbers, is going to have 0, 1. That would be over nothing up 1. It would be right here. So the two blue points were on the original graph. The two purple points are on the inverse. All you got to do is draw the line that goes through the purple points. Oops, it's not a great line. It's a little bit hard for me to draw lines on the PowerPoint, but you guys get the idea. That purple line right there is the inverse. And I did it by picking any 2 points on the original line, switching x and y, plotting the new points, and then graphing the line. So both of our first two examples were all about points. It was about taking a point, switching the x and y, you have the inverse. For our last example, or for our last topic, let's talk about when you don't have points, when you have an equation, like a line, y equals mx plus b. Now what we're going to do, if you want to find the inverse of an equation, it's still, remember I said, as soon as you hear the word inverse, the first thing you think of is switch x and y. So we're going to do that, but in the equation. So you have y equals mx plus b, you're going to switch the x and y, it's actually going to be x equals my plus b. You're going to flip the two letters in the equation. Now, one quick reminder, f of x is basically the same as y. So if instead of saying y equals mx plus b, it says f of x equals mx plus b, don't be confused and think that means you can't find the inverse or anything. Just change it. Change the f of x to a y for this problem, and then switch the x and y. So once you get to that point where instead of y equals mx plus b, it says something like x equals my plus b, to finish finding the inverse, you need to solve the equation for the new y. So let's try one of those. Find the inverse of, and then our equation is f of x equals 3x minus 10. So right off the bat, I threw one at you that I talked about in the last slide. I said you look at it and you go, well, I'm supposed to switch x and y. I don't even see a y. Don't worry about it. Just rewrite the equation. Say instead of f of x, I'm going to call it y equals, but then the rest of it's the same, 3x minus 10. Now, we're going to switch the x and the y, and what I mean when I say switch the x and the y is anywhere you see a y, write x instead, and anywhere you see x, write y instead. So I switched the x and the y, I just took them and I flipped spots. Instead of y equals 3x minus 10, I have x equals 3y minus 10. Now by switching x and y, you actually created an inverse function. But in order to see what the function is, we want it to be in y equals form like our original function. So I have two extra steps here. If I want to solve this equation for y, the first thing I would probably get rid of is that minus 10. And to get rid of a minus 10, we use a plus 10. And then of course, remember our number one rule for equation solving, you can do anything you want as long as you do the same thing to both sides. So I'm going to do a plus 10 over here with the x too. So those 10s are gone. The x plus 10 is just x plus 10. And it equals, now the only thing that's left is the 3y. Now to finish solving for y, I got to get rid of the 3. And I would do that by dividing everything by 3. So divide everything by 3. And we actually got our answer here. We have, it's written backwards, I'll rewrite it in order. We have y equals x over 3 plus 10 over 3. Now let's talk about that x over 3 for a second, because in y equals mx plus b form, we don't want x over some number. We want x times some number. So I'm going to turn this into a fraction, and the way I'm going to do it, I'm going to realize when I have an x all by itself, it's actually a 1x. So what this is, it's not x over 3. I mean, it is x over 3, but another way of writing it, instead of x over 3, would be 1/3 x. Now the second one, 10 divided by 3 doesn't divide evenly, so I'm just going to leave it, 10 over 3. Now for my final answer, let's just, instead of having the equation equals x, or equals y, let's flip it around and have y equals. So for my final answer, I'm going to say y equals 1/3 x plus 10/3, or 10 over 3. And that's your inverse function. So the inverse of y equals 3x minus 10 is y equals 1/3 x plus 10/3. And that came from switching x and y and solving for the new y.